All right, so this is number 30 from chapter 16, Mastering Physics. You have 0.004 moles of a gas. It undergoes the process shown in the figure. They ask, what type of process is this? What is the initial temperature? And what is the final temperature? So, first of all, what type of process is this? Well, it's a constant volume process. So that's an isochoric process. Right? So we have an isochoric process. It starts at 1 atmosphere of pressure. It goes to 3 atmospheres of pressure. And this all happens at a constant volume. That's what makes it isochoric. Constant volume of 200 cubic centimeters. So, one thing we should do is we should think about the conversion of cubic centimeters to cubic meters, right? So we know there's 1 meter in, or I should say maybe 100 centimeters in 1 meter. If you cube that, you get the conversion. That means there's, for every cubic meter, you have 10 to the 6th cubic centimeters, right? So then if we want to find the initial temperature, what do we know? We know P initial is 1 atmosphere, 1.013 times 10 to the 5th pascals, right? We want to put things in terms of SI units. And then let's see, we know the volume, the initial volume is 200 cubic centimeters. And using our conversion, 1 cubic meter over 10 to the 6th cubic centimeters, we get 2 times 10 to the minus 4 cubic meters. Okay, so let's see. We have initial pressure, we have initial volume, we know the number of moles is 0.004. So let's apply the ideal gas law. We know PV equals nRT. So T equals PV over NR. So T initial, P initial, V initial. Let's plug in. We have 1.013 times 10 to the 5th pascals times 2 times 10 to the minus 4 cubic meters, all divided by the number of moles, 0.004 times R, which is our universal gas constant, 8.31 joules per mole Kelvin. So if we solve, we get 609.5 Kelvin minus 273.15 Kelvin. That gives us 336 degrees Celsius. That's they ask for the initial temperature in degrees Celsius. So that's the initial temperature. Then they ask for, what is the final temperature? So actually what we can do, we know PV over NR is equal to the temperature, right? So we could use that, but we also know PV over T is equal to NR. In other words, PV over T is a constant. So why not just say P initial, V initial over T initial equals P final, V final over T final. We can do that. Set the ratios equal to each other. Now, the nice thing about that is that it's a constant volume process. So, cancel the volumes. You get T2 is equal to P2 over P1 times T1. So, take the ratio of the pressures. The ratio of the pressures is just 3, right? That the pressure changes by a factor of 3. So if you look, right, you start at 1 atmosphere, you end at 3 atmospheres. So all you have to do is say P2 divided by P1 is 3, and then multiply by T1 in kelvins, 609.5 kelvins. You get 1,828.5 kelvins, and converting, you're going to get 1,555 degrees Celsius. Rounding that to 3 significant figures, you get 1,560 degrees Celsius.